When we were discussing exponentials, you may have noticed something from their graphs, and that is that the graphs of exponentials pass the horizontal line test. That is, exponential functions are one-to-one, but their inverse isn't any of the functions that we know so far. In order to take the inverse of an exponential function, we have to introduce a brand new function called the logarithm. In particular, if some number to the x power is a number y, that is the same as saying that the log with the same base of y gives me the exponent back. So notice the base stays the same, x and y swap. Compare that to the way that we defined radicals. We said x is the nth root of y means that x to the n is y. In our definition of radicals, the index stays the same while x and y swap. So that means that we want to use a logarithm if we know the base and we need to find the exponent. Use a radical if we know the exponent and need to find the base. Before we work with them at all, let's take a moment to practice reading a logarithm. So this says the log base 4 of 8 equals 3/2. So we read this symbol as log base 4. We should not read this as log 4. Why? Sometimes we will write a log without a base. We'll talk in a moment about just what this means. But we would read this sequence of symbols as log 4. So when we mean log base 4, we should read log base 4. If we see a log without a base, we can just say log 4 or log of 4. Okay, now let's practice manipulating this notation. We just said the log base 4 of 8 is 3/2. How would we understand that in exponential notation? Well, 4 stays the base. I'll write a 4. And then 8 and 3/2 switch places. So 3/2 becomes the exponent, and 8 should be the answer. We'd like to check that that's true, so we'll compute 4 to the 3/2 power, and we see that we do indeed get 8. I'm going to have you try one of these. Rewrite the sentence, log base 3 of 81 equals 4 in exponential notation, and check that it is true. Pause the video and try this now. Alright, so the base stays the same. 4 and 81 switch places. So 4 becomes the exponent, and I claim that that equals 81. 3 to the 4th is indeed 81. So that is true. Of course, it's also useful to go the other way. Rewrite 27 to the 4/3 equals 81 in terms of logarithms. So the base stays the same. It stays 27. 81 and 4/3 switch places. I'm going to have you try one of these as well. Rewrite 2 to the 5th equals 32 in terms of logarithms. Pause the video and try this now. Alright, so again, the base stays the same. 5 and 32 switch places. So 5 is the exponent, 32 is the argument of the log, and I claim that that equals 5. Notice, since this sentence is true, this sentence is also true. Since this sentence is true, this sentence is also true.